All right, so for the partial sums, guys, it said we're just adding up the first 5 here. So we're literally just plugging in and doing kind of like the top part. So even though there's an infinity symbol there, the instructions say to add the first 5. So it is going to be 1 over 1 plus 1 over 2 plus 1 over 3 plus 1 over 4 plus 1 over 5. 1, 2, 3, 4, 5. And remember, all of these are being multiplied by 10. Any questions on how I set this up? Bless you. Y'all, I think the hardest part on this is the least common denominator. What's the least common denominator of 2, 3, 4, and 5? It's pretty big. Not too big. It's under 100. It's 60. For the sake of time, y'all, it's 60. We're going to write all of these with an LCD of 60. So 1 over 1, that's 1 whole. That's going to be 60 over 60. 1/2 in terms of 60 is 30 over 60. 1/3 of 60 1/3 of 60 is 20 over 60. 1/4, a quarter of 60 is going to be 15 over 60. And then 1/5, think about a clock, guys. We would multiply 5 by 12 to get 60. 1 times 12 is 12 over 60. Don't forget it's being multiplied by 10. So it is going to be 10 times something over 60. Let's add up all those numerators. Bless you. So 60 plus 30 plus 20 plus 15 plus 12 is going to be 137. And guys, when we multiply that by 10, it's going to be 1370 over 60. Those zeros are going to cancel out, and we're just going to leave it as an improper fraction. Let's just leave this partial sum as 137 over 6. Any questions on that? Okay, let's find the rule for number 7. Okay, to write this rule, guys, here's what I'm looking at. What is the only thing that is changing? The only thing that's changing is this number right here. And we need to write the sum. So I'm going to use my little fancy sigma notation here. And remember, the bottom number is where it starts. The lowest value I have right here is a 1. So I'm going to put a 1 right here. N equals 1. I'm going to write it in terms of n. I could write it in terms of I, x, whatever. I just chose n for number. And the highest, the last one, is 15. So the rule, guys, the only thing that's changing is going to be this part right here. So we're going to make that an n. And that's it. That's the answer. So remember, whatever is changing is the variable. I'm just going to always write it in terms of n. All right, let's look at this last one. So for this very last one, everything stays the same except the numerator in this fraction. It starts at a 1, but we're going to stop this at 6. So again, my sigma notation, it seems like the lowest one is 1. So n is going to start at 1. It's going to stop at 6. These are the numbers that are changing. So it is going to be 1 minus n over 6. Only that fraction is being squared, but these are being combined. And that's going to be the rule for the last one.